Welcome to MED-MYSTIFY. Inside a typical household medicine cabinet, rows of orange bottles and white boxes contain more than just active ingredients. On these labels, suffixes like XR, EC, or Forte appear alongside the drug names. While these often go unnoticed, they represent specific engineering choices made by pharmaceutical scientists to control how a medication behaves. These letters serve as technical specifications, dictating the exact timing and the precise biological location where the medicine must activate. Bypassing these instructions, by taking an IR version when an ER was prescribed, or by crushing a pill, can cause the medication to enter the bloodstream at a rate the body isn't prepared to handle, potentially reaching toxic levels. Understanding these abbreviations reveals the meticulous ways engineers manipulate human biology to ensure a dose remains effective over time. One of the primary hurdles in drug design is the problem of time. If a patient swallows a standard pill, the body tends to process and absorb the entire dose into the bloodstream almost immediately. As seen on this graph, when a dose is released all at once, the blood concentration spikes rapidly. It often crosses the red threshold, where side effects become likely, only to plunge back down into a crash zone, leaving the patient without enough medication to be effective. This rapid delivery is the hallmark of an IR or immediate release formulation. Doctors use this when a fast peak is necessary, such as when treating acute, sudden pain. To avoid that cycle of spikes and crashes, engineers developed time controllers. Labels like SR, CR, MR, and XR are designed to transform that sharp peak into a long, smooth curve that stays within the optimal therapeutic zone for hours. These formulations use specialized internal structures to drip-feed the active ingredient into the system. This allows the body to maintain a steady, effective state rather than reacting to a sudden chemical surge. When you see these suffixes, it means the medication is designed to prioritize long-term stability over immediate impact. Beyond timing, a pill must survive its journey through the body. Its first major obstacle is the stomach, an environment filled with highly corrosive acid. This acid can destroy delicate drug compounds before they reach the bloodstream, or the drug itself may be so potent that it causes severe irritation to the stomach lining. To navigate this, engineers use physical shields, indicated by the letters EC for enteric coated or DR for delayed release. An enteric coating is a specialized layer that remains solid in the presence of stomach acid, keeping the medication inside completely protected. This schematic shows how the shield works. The pill passes through the acidic environment of the stomach entirely intact. It only begins to dissolve once it reaches the alkaline environment of the intestines, as shown here in blue. The EC and DR suffixes indicate that the pill is an armored delivery vehicle, engineered to activate only when it reaches the correct destination. Sometimes controlling timing and location isn't enough. Certain conditions require a higher concentration of the medication than a standard dose provides. In these cases, pharmacists use suffixes like DS for double strength, or the suffix Forte. These indicate a formulation that has been scaled up to deliver a significantly higher active dose in a single pill. A plus formulation, or a plus symbol, indicates a different engineering approach. Instead of just more of the same drug, a secondary ingredient has been added to work alongside the primary one, increasing the overall effectiveness. These suffixes serve as a direct notification that the medication is a high-strength payload, carrying more biological impact than the standard version. By identifying these suffixes, you can see the technical design behind a prescription. These letters are as essential to the treatment as the name of the drug itself. This leads to a critical rule for patient safety. Never crush, chew, or split a pill marked XR, SR, or EC without a doctor's approval. Crushing these pills physically breaks the time-release structure, or the acid shield. This can cause the entire dose to flood the system at once, potentially leading to toxic levels that the engineering was specifically designed to prevent. These small abbreviations are the boundaries that ensure a medication remains a safe, effective tool, rather than a biological hazard. Thanks for watching MED-MYSTIFY. If you found this look at pharmaceutical engineering helpful, like and subscribe for more.